Hello and welcome back. This is Greg French. Today we're going to conclude Chapter 5. This will be Chapter 5, Part 4 in our A+ computer repair series, CPUs and chipsets. Installing a Pentium 2 in slot 1. Before beginning the task, follow safety procedures. The summary of the 7 installation steps. Unfold the universal retention mechanism, the URM. Determine how the cooling assembly lines up. Fit the heatsink to a single edge contact cartridge, the SECC. Secure the cooling assembly to the SECC and insert the cooler and the SECC into the supporting arms. Lock into position. Connect your power cord from the fan to the power connection. Here's an example of the SECC and the slot 1. It just inserts directly down into it. And there's some retaining clips on the side. Insert the heatsink fan and SECC into the supporting arms on slot 1. Here we have carefully push the controller assembly clips into the retention mechanism on the motherboard until they snap into position. Here we've got some different types of clips for the Pentium processor, and they clip on. Installing Pentium 4 into a socket 775. The socket 775 has a lever and a socket cover. Cooler is installed between steps 4 and 5 below. And here's a summary of the 5 installation steps. Number 1, release the lever from the socket. Lift the socket cover. Place the processor in the socket. And then close the socket cover. Connect the power cord from the fan to the power connection. After the components are installed, verify the system works. Here you can see on the bottom of this processor, this copper color, there's a little bit of a paste here. This paste is put on to help transfer the heat from the top of your CPU to this heatsink. The cooler is installed on the motherboard using 4 holes in the motherboard. These little clips go down through the motherboard, and that's where it's inserted and fastened. Here we got the CPU, and motherboard temperature is monitored by the CMOS setup. Within your CMOS, you can actually watch the temperature increase as you first turn the computer on. You can also set up some warnings for certain voltages as it reaches certain voltages. Also, you can set up a shutdown in case temperature exceeds a certain amount. Usually by default, these are not turned on, so it's always a good idea to go into your computer and set them up. In summary, basic CPU components. We have the I/O unit, the control unit, and the arithmetic logic units, or the ALUs. We have registers, which are used by the ALU in current processing. Internal cache holds frequently used instruction. The operation of the internal cache extremely important to the performance of the CPU. Remember that story I told you about the Celeron? Engineers did a very good job on that cache, and it was able to outperform the current Pentium 2, which retired the Pentium 2 since the Celeron was selling at a less price or less expensive. Types of buses in the CPU, internal and external to the system. So we have internal buses and external buses. Internal buses run extremely fast compared to the external. Standard Intel Pentium features since 1993, 2 arithmetic logic units, 64-bit external path size, and then 2 32-bit internal paths. But today, everything internally is also 64 bits. Processors are housed inside a processor package. Processors fit into slots or sockets on the motherboard. It's pretty much just sockets today. We don't use the slot. The chipset controls the memory cache, external buses, and some peripherals. Very important, the North Bridge is probably one of the most important components on your motherboard as far as performance, controlling that bus speed to the CPU and also the bus speed to the memory and to the video card. A controller comprises a controlling fan and heatsink. A cooler comprises a controlling fan and heatsink. A voltage regulator module, which is the VRM, controls the amount of voltage to the processor. This is real important because we do have internal voltages on the processors which are much lower than the voltages on the motherboard. So we take the 3.3 volts or the 12 volts and reduce it down to less than 1 volt for our internal voltages for the CPU. Activities, research, installation problems, and discuss. There are some problems, especially with the land grid array. There were a lot of damages both to the chip and to the motherboard. I want you to do some research, and we'll discuss that. Lab 5.5, CPU heatsink installation. I want you to go through that. We're actually going to do some hands-on installation of CPUs just so that you can get familiar with this procedure. There's also some review questions at the end of that I want you to turn in. Also don't have it listed here, but it's going to be a test on Chapter 5. You'll find that on Exam View. That's it. Thank you very much. Bye.